Hello everyone, it's Ethan, and today I'm going to walk you through my analysis of the Los Angeles crime data. During this presentation, we'll look at the questions I asked, how I prepared over 1 million police records, and created 2 models to help the LAPD know when the crime might spike or where they should focus their resources. Project background. The Los Angeles publishes every crime incident since 2020 for public transparency. That openness lets us find patterns that can quite literally save lives, whether you're a tourist on the Walk of Fame or a current resident of the city. The dataset spans from January 1st of 2020 through March 13th of 2025 and contains more than 1 million rows across 28 variables. I'll have the link found on the next slide, where there are a lot of great publicly available data sets that the government allows the public to have. Our problem formulation. I framed this project around 4 practical questions that the LAPD and the LA community cares about. Number 1, are crime volumes trending up or down? Number 2, which neighborhoods experience different crime types? Number 3, do times of day, location, or age make certain crimes more likely? Number 4, given the limited officers and budget, how can the department deploy people and programs more effectively? Data strategy plan. To answer these questions, I downloaded the public SSV file, loaded it into Python, and planned 2 models: a time series forecast for when questions, and a k-means clustering model for where and what questions. Before modeling, though, we need to clean up reliable data, so let me show you how I turn raw records into useful information. Also, there's a link for anyone wanting to actually see the data themselves. Data cleansing part 1. First, I trimmed excess baggage. That means internal case IDs, redundant crime code columns, and fields with too many missing or unusable values. I also fixed corrupted gender symbols and removed zeros that meant unknown. A lot of the ages were 0. I don't know about you, but I don't typically see crimes happening with people that aren't born. So I put those as unknown. Dates were stripped of default midnight timestamp, as there was a time occurred column, which actually gave us the time of when these crimes occurred during the day. Data cleansing part 2. Next came feature engineering. I grouped the 24-hour clock into 4 known groups: morning, afternoon, evening, and night. This grouping helps the public and the department understand time as a whole and not so scattered throughout the day. It lets us look at 4 individual time groups. So I rolled 1,200 individual crime codes into 10 big themes, like assault, theft, or sexual offenses. Crime codes, there's thousands of them, from like, did the person punch someone? Did the person threaten someone with a fist? So imagine all the different possibilities that you can do with your hand, and times that with any other object or thing occurring. They have a crime code for it. So I just took those crime codes and grouped them until there was no more any lingering crime codes. I also created groups for different weapons, like battery weapons, arson, and stuff like that. The premises of which these crimes and incidents have occurred, either a neighborhood, some kind of commercial building, industrial building, you name it, I grouped it into those, and as well as the victim ages, like baby, teenager, adult. So there's not so much variety. We can look at these groups and further explore those. These new columns expanded the data set from 28 features to over 52 variables without losing a single row. exploratory insights. Even before modeling, some patterns did jump out to me. Vehicle-related offenses led the pack, and crimes occurred surprisingly evenly across the day, something that you will see visually in a moment. These insights guided the variables I fed into the two models. Starting out with our crime density map, here's the first visual, a heat map of more than 1 million crime coordinates. The dataset had the coordinate locations. I decided to keep them because I knew it's a possibility to actually create a map with these coordinates, and I wanted to see where these crimes are occurring across LA. So this is my first visual. The red zones, as you can see, are more downtown, South LA, and parts of Hollywood. These are the high density areas, more popular areas of LA, I would say, for tourists. Also notice there's also a corridor stretching south into Long Beach, that little, pathway down there that tells us hotspots policing can't be limited to just downtown. It needs to be broader and more of a regional view as well. So moving on, we have our crime by time of day, which really surprised me. This bar chart groups those incidents by time of day. Night and afternoon, you can see a slight uptick, but the takeaway is that the crime is a 24-hour phenomenon, or however you say that word, excuse me. Morning, while it's the lowest, is only about 10% below evening. So any staffing plan the LAPD should come up with, they should consider around-the-clock readiness. Next is our ethical considerations. Open data like this is powerful, but it carries a lot of responsibility, especially mapping hotspots like I've done could unintentionally group neighborhoods or depress housing prices. Likewise, breaking crimes down by age or gender can risk enforcing stereotypes. Throughout the project, I kept any personal fields out and focused on prevention rather than blame, and I framed these results as tools for the community to gain trust and not to justify any kind of blanket surveillance or targeting certain groups. Slide 12 is the new tools I used during this report. Now, this is like the models that convert rows into columns. I used forecasting, which tells us when crimes might surge. Clustering shows when and where and what type of crimes each area focuses on, and so on. This is all done with Folium, GeoPanda, Shapely, and that's what helps us draw those areas on the map. And for modeling, like I said, I used a new ARIMA algorithm, which is from the Stats Models library. On to from data to decisions. This is where we can use those models together and help the LAPD stretch every tax dollar to ensure public safety and ordinance within the city of LA, using that forecasting model and clustering model as one big tool. So starting out, forecasting daily crime counts, I aggregated the dataset into daily totals and split it in chronologically order. Everything before December 13th, 2024 was used for training. That is 90% of the data. The most recent 90 days for testing are used. So everything from December 14th to March 13th, that was our test group. The ARIMA model is like a smart line reader. It spots repeating patterns, long-term drift, and sudden jumps, and then projects them forward. So it gives us an in the now, what is going to happen kind of prediction based on past events. Key results and use cases. On unseen data, the model's average miss, called mean absolute error, is about 192 crimes, and the root mean squared error is 206. Given LA averages around 3,500 incidents a day, this is useful to a -6 to a +6% window. If the line tilts upwards next month a commander at the LAPD can schedule extra patrols or overtime in advance. If it dips, then they can reallocate funds to community programs instead. Now for a K-means clustering. For spatial insight, I built crime profiles for all 21 LAPD areas that they categorize. And then these profiles include percent theft, percent domestic violence, percent nighttime offenses, and so on. The K-means clustering then groups these profiles into 6 buckets that are sharing similar patterns. 6 struck the right number to me because I didn't want to have a lot of groups, and less than 6 felt like too little since there are over 21 different areas. I'm sure there's some variety between them. Now for the result of our K-means, I created this cluster map, and it paints the clusters across the city. If you actually have the map, which is an HTML document, you can hover over and it will tell you what area it is. But it's a presentation, so in a video, can't do that. But I'll tell you what each area is. So cluster 0 in that red, it suffers mainly from property crime. So think break-ins, so better lighting and neighborhood watches make more sense in those areas. Cluster 1, the blue, you can see more domestic incidents. So think family issues, like violence that's at home. And I believe more social outreach, especially to families, can also help. Even like AAA meetings, you know, we don't want drugs in the house because we want to keep a friendly neighborhood. Cluster 2, the green, it blends car theft and burglary into the same kind of group. This suggests joint traffic and burglary units patrolling those areas. Cluster 3, the purple, is our violent crime hotspot. Here, tactical units should be stationed nearby as there's more signs of assault, murder, and so on. Those that you don't want to send unarmed officers in when there's a crime. Cluster 4, the yellow, is moderate across the board. That means it could include the same number of domestic crime as burglary crime. It's not really showing any signs of a popular crime type, so it's give or take neutral. Cluster 5, the orange, combines vehicle crime with violence, needing a hybrid strategy. That means like car theft, auto theft with assault charges or anything like that. You don't really want to drive a car through that area, I would say. Instead of tailoring the policies at the LAPD for over 21 different areas, they can focus on 6 clusters, as you can see in the map. So it should really help them out. Business insights gained. Let's put together the models, act like a crime early warning system. If a forecast spikes, let's look at what cluster groups are more violent or vehicle crimes that are more likely to occur in certain areas, and staff our patrols accordingly. The city can synchronize police, social workers, and infrastructure upgrades like streetlights, CTVs, and shelters for those who need. And this is where we can exactly see where and when they're needed. Slide 18 is to recap. We claimed and enriched our over 1 million public crime records, visualized key patterns. We built 2 models that answer our 4 starting questions. The forecast model reveals when crime fluctuates. The cluster map shows where and what types of crime dominates in that area. Together, they both guide resource allocations, they inform community outreach, and ultimately they aim to make Los Angeles both safer and more of a trusting police force. Thank you for your time. I look forward to seeing what everyone else did for the report. Bye.